Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, I'm Tutor Joseph of Mr. Explicit. Please, as you're watching this video, endeavor to subscribe, like, share, and comment. If you know you haven't watched the videos on mirrors, I will advise you do so for a better understanding. And today's video shall be doing an extension of lenses. Alright, I told you guys that lenses are optical systems having two refracting surfaces, and lenses are commonly made up of what? Glasses. But in some cases, they can be made up of what? Plastics and what? Crystals. Alright, take note that lenses have two focal lengths and two center of what? Curvature. And please, we said that in lenses, we said that in mirrors, the radius of curvature is twice the focal length. That is, radius of curvature is equals what? Twice the focal length. But in lenses, that is not the case. If I should express this, I'll be having f equals what? Arrow over what? 2. In mirrors, f is equals arrow over 2, which is coined from this place. But in lenses, f is not equals arrow over 2. So which means that f is expressed alone, then arrow is expressed alone. They are expressed independently. But in mirrors, f is always equals arrow over what? 2. Take note of that. Now, please take note that the images formed by a convex lens and convex, let me use mirror here. The image formed by a convex mirror and concave lens are the same. The images formed by convex mirror and concave lens are the same. They are always what? VED, which means virtual, erect, or upright, and what? Diminished. Diminished. Alright? If I don't use the word diminished, I will use reduced. Alright, so the image formed by a convex mirror is same as the one formed by a concave lens. That is VED, virtual, erect, upright, and what? Diminished. Take note of that, okay? In a convex lens, the images are formed based on the position of what? The object. Alright, and in concave mirror, the images are formed based on the position of what? The object. Take for example now, if I have something like this, if I have a plane and I have here 2f and I have f, around this region I have my lens f1 and what? 2f. If I should place my objects at f and I bring it like this very one will cause, this region is the center of curvature, right? It will cut through this region. Is that not correct? It will cut through the region, while this one will also cut through this region. It's not straight enough. There's a way you can actually do that. You know, I'm not using a rule. So you have this. Now, what will you observe? All right. From what we have illustrated now, this is where the object is. All right. This is where the object is. So what? Oh God, this thing is not straight enough. It's not straight enough. I'm trying to straighten it. So what will you observe in this case? This is where the object is. It means that the image is what? Upside down. This is the object and this what? The image. What does that tell you? It means that it is what? Upside down. Therefore, when an object is placed at 2f, when an object is placed at 2f, one, the image is real. The image is what? Real. 2, it is what? Inverted. That is upside down. And it is same as what? The objects. They have the same length. So they are same as what? The objects when an object is placed at what? 2f. You see, real inverted at what? Same as the object. What about when an object is placed? If I have something like this, 2f, and I have f1, and I have somewhere around this region my length, this center of curvature, don't forget, I have f1 and I have 2f. Alright? If I should place an object between 2f and f, if I should place an object between 2f and f, what did I tell you? The first one will always cut through. We always cut through what? The center of curvature, right? We always cut through the center of curvature. This thing is not straight. Now, what about this other one? It will cut through this region. So, from what we have illustrated now, when an object is placed between 2f and f, what does that tell you? It means that the image is what? Inverted. It is real, inverted. Alright, inverted. What will you observe? Magnified. That is larger than the object. It is larger than the objects. Apart from that, what will you observe? It is formed beyond 2f. You see now that the image is formed beyond 2f. Alright, you can use your rule to take an accurate measurement of what I'm doing now. Please take note of what we are doing right now. But if I have a plane, I have an object placed at, I have a surface, and I have 2f here, and I have f, I have my length, I have f, and I have 2f. When an object is placed beyond 2f, don't forget your radius of curvature. I have something like this. This first one I told you will always cut through the radius of what? Curvature. Alright? To cut through this region, which is radius of curvature. While this other one cuts through this region. So what would you observe? Where is the image formed? One, the image is definitely real, upside down, inverted, which one again? Formed between to have that's why if you should use your rule, you have a better value. If you use your rule, you have what? A better illustration. Here I'm using my bare hand. So the image is formed between f and 2f. So what will you observe? You will observe that this image is actually larger than the objects. All right, larger than. Don't forget to arrow. This one is coming this way and like this, going down. So they'll meet at this region. So larger than. These markers, people are not well. Larger than the words objects. That is when an object is placed beyond 2f. Now, apart from this, when an object is placed at f, if I have f here, and I have my lens, and I have f here, so what kind of image is formed at f? Don't forget, you have to like this. This first one pass through the center of curvature, and the other one pass through this region. So what did you observe? I think with this, you know what to say already. Please, when an object is placed at 2f, all right, when an object is placed at 2f, what does that tell you? It means that the object, the image formed will be at what? Infinity. Infinite, like is going. The image formed will be at what? Infinity when an object is placed at what? 2f. All right. So when it's placed at f, sorry, when it's placed at what? F. Now, please, the characteristics of an image formed when an object is placed at f, I call it real. It is real, inverted, real inverted, and is formed at 2f. If I have 2f here, and I extend this, you see now there will be a meeting point. You see that? So it is, don't forget. So from what I've written, the major thing you should note here is that when an object is placed at f, what will you observe? The image will be at what? Infinity. Look at it's going, all right? So take note of that, okay? Is there any other one? Please, this one is very important. Very important. When an object is placed between f and lens, all right, if I have an object around this region that's between f and lens, I have this one cut through, I have f as well, this one cut through center of curvature, then this one come like this. So what will you observe? One, the image is what? The image is virtual. The image is upright. It's not inverted. You see, it is not. Look at where the image is. Then two, where is the image formed? The image is formed behind f. All right, the image is formed behind f, and what do you observe again? The image formed, it's larger than the object. Very true. The image formed is larger than the objects. So please take note of this. We are done with today's class. Please do it carefully. If you want to have an accurate value of what I've just done, use your rule and your pencil to draw properly so you have an accurate illustration. All right. So if you know you have learned something in today's video, please endeavor to subscribe, like, share, and comment. And my next video is going to be based on calculations involving lenses. All right. Please take note of that. Do have a wonderful day.